right, system of linear inequalities. So this goes back, it's really nothing we haven't done before. Remember, if you had a system of inequalities, this is just one inequality. So you graph these just like a linear equation. It crosses at -3. It's got a slope of 2. So you put a 1, you rise 2, run 1. Now here's where there's a couple things a little different. Remember what we got to do now?
3 over 1.
Oh, shade.
We got a shade and dotted. It doesn't have the equal to. If it has the equal, you put a solid line. If it's not, you put a dotted line. And then, like you said, we got to shade one side or the other. Since y is less than, that means we shade below. So a system, remember, is 2 or more. We're just doing, well, some of these will have 4 or 3, but they'll be real easy ones. Horizontal lines and vertical lines. So if we had another equation, okay, if we had this one, y is greater than or equal to -1 half x plus 1. It crosses at 1. The slope is -1 half, so we go down 1 over 2. This one does have a solid line. And then its y is greater than, so it's everything above it is shaded. Okay? So, everyone follow what we're doing so far? Nothing new. So now the solution of a system of linear equations is everything that's shaded by both parts. So every coordinate in this region would be a solution to those. Okay? So, like I said, a lot of them, we just have these. They did the graphs for us on all of these, but y greater than or equal to -3 just crosses the y-axis at -3. Greater than is shaded above. When you do these, you might want to just go really lightly with your pencil, or if you want to use colored pencils, you guys know where they're at. You could do each one a different color, then it's easier to see. Then this one, x is less than 2, crosses the x-axis at 2, and it's dotted. So you can see they've made a dotted line here. Less than is everything shaded this way. So this one was up, this one is this way, so now everything here is shaded. And then when you graph this one, crosses at 1, it's got a slope of 1, so you go up 1 over 1. That one does not have the equal, so it's dotted. So again, remember, if you were shading it, everything up here would be double shaded. But this is y is less than, so you shade below. So that means everything that is shaded by all 3 is in that triangular region there. Okay? Now the 2 that are kind of confusing, and they throw these in a lot. X is greater than or equal to 0. When it's like a number, these are easy to do because it crosses at 2, and we know it's got to cut through there, so it's not going to go this way, it's got to go this way. But when they put 0 in there, that one gets a little confusing what to do. Because it's right there and it's right on. It's kind of hard to see where it goes. So you just got to remember, it's going to cut through the x-axis at that number. So x greater than 0 would be the actual y-axis, and it would be shaded this way, right? Then they throw in y is greater than or equal to 0. That's going to cut through the y-axis at 0, so that means it's got to be this line. And greater than or equal to is shaded above. So the part that's shaded by both is this part, right? Now they throw these in a lot of, not just these problems, but in, these are used in business, manufacturing. Anyone know why they have these a lot, like in a manufacturing problem? When you see what the graph looks like?
Because it would all be even or then positive.
All positive. This is the only all positive quadrant, right? And when you manufacture something, you can't manufacture a negative amount of something. So these are usually always two restrictions on the manufacturing problems. Okay? Eventually what we're going to get to is, well, maybe this is algebra 2. It's probably algebra 2 that you do this. They have a manufacturing problem and they throw this in there, and usually what they do is they do two types of things. So if they graph one of them, say it goes like that, and it's less than, and then they graph another one, and it's less than, that means this part is shaded. Now this has to do with their budget, how much they can spend. So like the point, any point in here is a solution. Like say they're building boys' bikes and girls' bikes. This would be boys' bikes, we'll just say, and this would be girls' bikes. Say it's by the thousands, this would be 2,000 and 3,000. That could be possibly budget-wise, they could build that many bikes. But what they do to use this is this point, this point, this point, and this point. This point right here is going to be the maximum profit they could make. If they figure out what that coordinate is, the amount of boys and girls bikes. You understand what I'm saying? So that's how this is used in manufacturing. But again, I might be getting that crossed up with algebra 2. I don't remember now. So here's a real simple one. They graphed x is less than 2 and x is greater than -4. So that's the graph of these two. Everything in between is shaded. So here's one where I showed you they've got x is greater than or equal to 0, y is greater than or equal to 0. So when you see that, you just know it's going to be in the first quadrant. So you really don't even need to put those on there because you know it's going to be that part shaded. Then when you do the other ones, y is less than or equal to 1 is this line. Less than is below, so that means everything here is shaded, or right here. And then when you do this one, it crosses at 3. The slope is negative. So you go down 1 over 1, down 1 over 1. Y is less than, so shaded below. So that is the region that's shaded by everything. Does it seem hard? Good.
So you're just supposed to fill in this like part where.
Yep.
Okay.
That's why if you want to use the colored pencils, and you can take them with you if you want, just bring them back. To shade different colors, then it's easier to see. Otherwise, just shade, you know, like you can just put light lines going different ways. So there you can see it shaded there, and we already know that that means it's in the top quadrant. That cuts it off like that. Okay, so here's another one. Crosses at 2, slope of 2, so up 2 over 1, dotted line. Y is less than. So remember when you figure out how that shade goes to where it crosses the y-axis, less than is below. So that means everything below is shaded. Then with this one, crosses at -1, go down 1 over 2, dotted line. And y is greater than, so it's everything above. So if you just use a pencil, if you put them on different angles, the lines, you can see where they cross. So then just go back in and shade in like that, where the double region is. So again, here we know this line is x is greater than, because it's dotted, -2, shaded to the right of it. This one is y greater than or equal to, because it's solid, 1. Once again, they tell us this so you know it's going to be in, oh, no, they switched it up on us. X is greater than 0, y is less than 0. So greater than 0 on the x is this way, less than is here. So that's why it's just this quadrant that's shaded now. I didn't know they threw any of those in there on this. Okay, so this one greater than or equal to -3. So this line greater than is above. X minus 4 crosses at -4 and the slope is 1, so you go up 1 over 1. Greater than means it's shaded above, so that's why this part gets shaded. So I got